Today I'm very excited because today we're going to talk about solving system of 3 by 3 equations. We have 3 equations, 3 variables. We already know how to solve a system of 2 by 2 equations, and the idea is still going to be the same. We want to somehow transform this 3 by 3 system into 2 by 2 system. Once we transform it into 2 by 2 system, we know how to solve that one. Okay, so let us see the steps how we transform a 3 by 3 system into a 2 by 2 system, and then we solve for 2 of the variables and then substitute back and find the last third one. Okay, so guys, the equations are right here. So what we are going to do is we are going to look at the equations carefully, and then we are probably going to, in this case, we're going to kind of group these equations together. Guys, if you look at equation 1 and 2, I can see there's a -1 and a plus y, right? Minus y and a plus y. So if I forget about the equation 3 for a second, if I just look at equation 1 and 2, and if I just kind of add those two equations using the basic mathematical operation of addition, I can get rid of those y's and I'll be only left with x and z, right? From 1 and 2, okay? So keep that in mind. Similarly, if I, for a second, if I just ignore number 1 and if I just focus on number 2 and number 3, the same thing. There's a plus y and there's a minus y. And if I add those two again, I would be left with x's and z's. So what does that mean? That means if I group these two, and then if I also group these two, then if I add those equations, I should be left with two equations with x and z. So that means I have transformed this 3 by 3 system into a 2 by 2 system, and we know how to solve a 2 by 2 system. Okay, so guys, I think the key concept that one has to kind of focus on and try to understand is how to transform this 3 by 3 system into a 2 by 2 system, and then we know how to solve a 2 by 2 system. Okay, so let's go ahead exactly what we talked about. So I'm going to bring 1 and 2. So it's x minus y plus z equals to -1, and then I'm going to write the equation 2, x plus y plus 3z equals to -3. Okay, so if I add these two, see what happens. If I add these two, guys, you already know that we are allowed to use any basic mathematical operation, whether you want to use addition, subtraction, multiplication, or division. Okay, so here I get 2x, this crosses out, and if I add these two, I get a 4z, and when I add these two, I get a -4. That is my first two equations transformed, and it becomes this equation in terms of x and z. Now, if I look at this equation, I should again ask myself, can I simplify this further? And the answer to that is yes, we can simplify this because this has a coefficient 2, 4, and -4. They're all divisible by 2. So I'm going to divide this by 2, this by 2, and the third term as well by 2. So what am I left with? X plus 2z equals to -2. So let us preserve this and put it in a box. So that is going to be one of my equations that we will need in order to solve for x or z. Similarly, we talked about combining these two as well. Guys, you can use these equations as many times as you like. So on the side, we are going to take x plus y plus 3z equals to -3, right? And then I have the equation number 3. 2x minus y plus 2z equals to 0. So there's one quick thing that I want to mention here. Sometimes my students also get a little confused with that, is the fact that, hey, we already used this equation here to simplify and get this. Can we still use it again? Guys, yes, we can use it as many times as you like, okay? So that's why we use it here. Now, when we add these two equations, again, we're trying to simplify and trying to isolate variables here. And we can see that the plus y and minus y will cross out. And if I add these, I get 3x plus 5z equals to -3. Okay, so I'm going to put that in box. This equation has x and z. This equation also has only x and z. So let us bring these equations together and then see what we can do with these equations. So I'm going to write it here. X plus 2z equals to -2, right? And then the other one is 3x plus 5z equals to -3, correct? Now, if you look at these two equations, we know how to solve this equation for a particular variable. Now, there's again a few different ways of doing it. What I'm going to do here is I'm going to multiply the first equation by -3 because I see a +3 here. If I multiply this by -3 and add them, I should be able to get rid of the x's, okay? So I'm going to multiply first equation by -3, and you already know why we are doing it. Now when I multiply this by negative 3, it transforms into negative 3x plus 2, sorry, not 2 anymore, because negative 3 times 2 is not even positive, it's negative 6z. And when I multiply this negative 2 by negative 3, we have to multiply each and every term by negative 3. I get a positive 6, correct? And then I also have my this other equation, which I'm just going to rewrite. Again, keep in mind we are aligning vertically the x's as well as y's and the constants as well. Now you already know what to do from here. You want to add those two equations so that you can eliminate or you can get rid of one of the variables. Here in this case is the x. So this crosses out. Negative 6z plus 5z is just negative z, and 6 minus 3 will be positive 3, but you just want z by itself. So to get z by itself, you have to divide both sides by negative 1. You get z equals to negative 3. Okay, guys, once we have z, or we have the values for one of the variables, then we can figure out the rest of them very easily. So you have z equal to negative 3. I can go back to this equation or this equation and solve for x. So let us use this equation. So using this equation right here, I have x plus 2 times z, which is negative 3. That equals to negative 2. We're going to simplify this. This is x minus 6 equal to negative 2, adding 6 to both sides. What do I get? I get x equals to 4. I have my x, I have my z, and now we want to find the value for y. To find the value for y, well, we cannot use this or this because this only has an x and z, so we want to go back to any of the, like these first three equations right here. So it's up to you which one you want to choose. Well, here, let us choose number 2. Okay, we're going to choose number 2 to find the value for y. So for number 2, I have x plus y, I'm just rewriting it, 3z equals to negative 3, and I'm going to substitute carefully my values for x and z, and then I'm going to find my y. So x is positive 4, y plus 3 times negative 3. Okay, let me actually write the step. So I have 4 plus y minus 9 equal to negative 3. When I combine like terms, I will get y minus 5 equal to negative 3. I have to add 5 to both sides. I'm kind of running out of space here. So this crosses out. I get y equals to negative 3 plus 5 is positive 2. So guys, I have the value for x, y, and z, and I have just enough room to actually put those together because we want to write them as a coordinate pair. So here it's not like, sorry, not a coordinate, there's not a pair here. These are like three values, but we want to just put them together. So it is 4 for x. X comes first and then y comes next. And the last one is the z. Guys, this right here is the final solution. Guys, it also says check your answers. And you know from my previous videos on system of 2x2 equations, we always want to make sure that we check our solutions and make sure that the solution is actually correct. So on your own, you should go ahead and substitute these values back in equation 1, 2, and 3 and verify whether this actually is correct or not. Okay. So guys, thanks for watching this video on system of 3x3 solving system of equations with 3 equations. In the next video, I'm also going to do one more example on 3x3 system, and then after that I think we'll start with our nonlinear functions. Okay, so till then, keep practicing. If you have any questions, just ask me.